We'll talk about logistics and the calendar and all that jazz in just a moment. But let's go ahead and let's just bust into section 5.2, T-proof, some of the harder ones. How many of you guys have already started 24? Okay, so everybody else, here we go. Let's start 24 in our notes. Let's not be lazy. This is the time when we dig in. To start 24, pick a side, and hopefully almost everyone, even in regular pre-cal, would choose what side? Yeah. If you choose the right, it's just going to be, well, you're going to have to be extremely creative and basically pull things out of the air that are true and valid, but still pulled out of the air. All right, as you guys look at this, I want you to, now this is really important, I want you to remember, first of all, you can't go moving something from one side to the other. You have to stick with one side. Hopefully you guys have gotten that by now. But second of all, I want you to consider your end. Oh, more life lessons. Consider the end, okay? That's one of the steps. I think it's actually something about, I don't remember the exact wording that was last week. Basically looking at the final result. You're looking at where you're trying to go. If we aimlessly wander through life or through a T-proof, it's probably not going to go well if we don't have a direction, if we don't have a goal, and if we don't press towards that goal. Yeah? Okay, same thing here. Where are we trying to get to? So who don't we want to get rid of? Probably. So let's not. Let's instead get rid of, what can we make cosine? Not sine. Cosine and sine. But if it was a squared, we could make cosine squared 1 minus, no, yes, 1 minus sine squared, but no. We can't put in squares because we can't do it to both sides. No squares. But what can we do? 1 over secant. 1 over secant. Secant. All right, let's go. Not exactly sure how it's going to happen, but let's go there. 1 minus 1 over secant. You guys remember my trick for simplifying complex fractions?
Not really.
Okay. Multiply top and bottom by the innermost denominator. Who's the innermost denominator? That guy. Get some parentheses in. Multiply top and bottom by the innermost denominator. Oops. Could you multiply this guy by secant over secant and combine and then multiply by the reciprocal? Yes, but you'll have to write like 3 different steps. My 1 does the same job. Because what happens when I multiply? Well, I don't know. Let's multiply the bottom first. What happens when I distribute? Because we want to get rid of that guy. What's that one going to do?
Secant minus 1.
Don't forget to write your thetas. Minus 1. Hey, does this look familiar?
Yeah.
So what if I don't multiply, and what if I keep in the bracket on top? For the express purpose of saying boo, yeah. Dun, 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 dun. Could you have gone a harder way? Yes. Could you have made secant 1 over cosine and gone that way? Yes. Could you have squared anything? No. You could not have squared anything. What do we do to finish the proof and say thus it has been proven? Rewrite it first. Say, hey, look, I've made it match. My work shows that. And then you can do a check, you can do a shaded box, you can do a QED or a rubber ducky, make George proud. There you go. One person did a Tyrannosaurus Rex, another person did a star, another person did...
I'm doing Donald Trump.
Do it. Coming back. Just do the hair. Okay, so, questions. We considered our end. We took steps to try to get there even though the path wasn't clear. Keeping it legal along the way.
Is it possible to multiply by the conjugation of 1 minus cosine theta and do 1 plus cosine theta to get 1 minus cosine squared?
And in some problems that might be smart.
Okay.
The problem is in this one, if you multiply top and bottom by 1 plus cosine, you would get 1 minus cosine squared in the denominator, which will help you get a sine squared, but it still won't get you closer to secant. So there might be other ways. Just some paths might be harder. But it does not mean that the path is wrong. Just be careful, you gotta keep it legal. At some point, it might be necessary to say this is not the right path, I need to stop and reevaluate. Life. Okay, love T-proofs. Number 29. What do you guys think?
Left.
Yeah,
Middle.
I agree.
No, all right.
Middle? Just write the equals and go team? No. Okay, so,
Got it.
left. What do you guys think? Considering the end, should we just plug in stuff right away? Should we do some math? Yeah, let's do some math. Common denominators, we had two different fractions. Let's do some math. Remember section 5.1? Factoring? No, it doesn't really apply. Foiling? No, nothing really to multiply. Common denominators? Yes. So we multiply this guy.
Oh.
Multiply this guy by, remember our example on Friday? Maybe it was on Thursday. The 1/2 and 2/3, you just have to multiply both of them by each other. That's what we're doing. Just with trig instead. Multiplying by 1 creatively to keep it all legal. The whole point of common denominators is to bring the fractions together, right? To take what both have to offer, bring it together, more life lessons, anyway. Once they have the common denominator, I can combine them. What have I not done yet? Because it's probably where most people would make a mistake in the math. I haven't foiled yet, did I? But I need to. Need to foil, no killing puppies. Who's foiled already? What does that become?
1 plus 2 sine theta plus sine.
You guys agree? Ooh, what do you see? Come on, you see it, don't you?
I'm writing it.
Yeah.
Yeah.
Sine squared theta plus cosine.
Equals? What can I substitute? Can I take this one down? Podium.
1.
Sine squared plus cosine squared as well. So if I take that, yeah, 1 plus 1 will be 2. Wait, 2 plus 2, can't I pull out a?
2.
Now pause. Sine squared plus cosine squared is? 1 plus 1 is?
2.
They both have 2 still?
Factor.
I'm not trying to skip lots of steps, but I'm also not trying to.
Confused.
Kill him.
Kill the puppies.
What I want to say probably isn't the best thing to say. Hold on. Have to write more steps than I need to while you guys are still trying. I don't mind skip steps as long as I can see the math. But if you skip from here to here, yeah, no. Does that make sense? I know, it's really funny though. There's actually a joke online, I'll show it to you guys. When you skip from here to here,
Cosby.
yeah, no. No, not the Cosby, but that one's funny too. Although you guys took a little while. Anyway, guys, why is this nice? Didn't we have one of these in section 5.1? It was super similar.
Cross it out.
Because we were able to then cross that out, and what's 2 over cosine equal?
2 secant.
Now, could you write 2 over cosine and then 2 secant? Sure. Could you just go straight to 2 secant if you see it? Because you're right.
You did it. I thought it was QED.
Yeah, but that doesn't mean it is. It just looks funny. Ryan.
For up by 1 plus 2 sine
Yes.
plus, yeah, that please. You get 1 plus 1, that's 2, I get that part. But then it would be 2 plus 2 sine theta.
Exactly. Factor out the 2.
Um,
Do you see it? So 2 plus 2 sine theta. You might just need to visualize it. 2 plus 2 sine theta, pull out the 2. You could rewrite it, 2 plus 2 sine theta all over, then factor out the 2. But I just factored out the common 2 that was in both. Does that make sense? Good. Question. Do these types match up to any of the tricky ones from the homework yet? Okay. There was at least one common denominator-ish one? And there was at least one, like substitute one guy for looking to the end for another guy. It might not be the exact same, might not even be written the same way. But I bet it somewhat corresponds. Maybe the ones you got, maybe the ones you didn't. Hey, we have 2 more. Ooh, number 32, left or right?
Left.
Why? I like your rationale, but I want to hear why you chose that.
Because we did it for the other one.
Because we've been doing left the whole time, that's an awful rationale, but sometimes it'll work. Keep going though, why left? Sometimes the right's better.
See a tangent.
Because the sins are always.
Okay.
Two columns on the left.
Did John have a valid point? Jonathan was like, hey, I see a tangent on the left, I don't like it, but that means I can plug in something for it. Is that true?
Yes.
Yes.
Yeah. On the left, you can change the tangent to get more sines and cosines. On the right,
You're already there.
what's another reason for the left though? Can anybody see the other reason that I'm
We
probably?
already have two cosines.
It's more complicated.
It's like separated.
I wouldn't say two cosines, I would say it's separated, which means I can always do common denominators. There's some math I can do. That's just what I see, doesn't mean that's necessarily how you see it. But I see I can do common denominators or tangent. What do you guys want to do first, the tangent or the common denominators? Sure, we can do common denominators. You're gonna get more tangents everywhere. Do you want more tangents everywhere?
We need less than two.
Fewer tangents. Hey, that could be applicable to some classes. Anyway, come back. Hopefully not ours. Question. Let's just go for the tangent and get rid of them. Look to the end, sines and cosines are all that we want. Ready, set, go. Choose the left, plug in, what is tangent? What's the property? I have to have these memorized. Sine over cosine. Are you memorizing them as you're using them?
For the most part.
Good. Maybe another purpose of homework is to make it so I don't have to study quite as hard. But then if you're not doing homework, then goes that theory. Then somebody else, yes, Carl. Is anybody else?
Are you doing it? The homework.
Yeah. Trying to get through examples, because that way when I come around to do the homework check, you guys can compare to the homework ones you got stuck on. And be seeing if some light bulbs go off.
Okay.
Also good.
We'll be doing that.
My turn, can I catch up?
That was just like nice. Good
How many of you guys really don't like that little cosine?
Sure. I know.
Use my trick. What did I say about simplifying complex fractions?
Denominator.
Top and bottom by the innermost. Who's the innermost?
Both.
That's most. It's okay, you just kind of squish it over. As long as I can see where it's going to, I won't knock it out. I'm not multiplying him by anything yet. I'm still not quite sure what that denominator is going to be. So I still have cosine x over 1 minus cosine cosine. What's going to happen in that denominator?
1 minus n. I mean sine.
Distribute, so cosine times 1 is, those cancel, I just get it. You guys like my trick for complex fraction?
Oh.
I do. For those of you that are tracking, it keeps us from having to multiply top and bottom by cosine, cosine combined. There we go, multiply by the reciprocal and simplify. Whew, 3 steps all in one. Trying to make me round it. On a mission trip, ironically. Okay, now what? Hey, it's looking kind of nice. Can I get this looking better?
Denominator.
What can I do to that to make it look like that? I mean, we still have to do common denominators, but what can I do to this? Yeah, can't I pull out a negative? Switch the signs?
Yes.
If I multiply that by a negative, it'll be minus cosine. If I multiply that by a negative, it'll be positive. And if I pull out a negative, it's a little messy. If I pull out a negative, it's going to be minus a negative, ultimately, when I switch the signs. Isn't that just going to be plus? The negative comes out, the whole thing has an extra negative, a negative, negative will be a positive. Okay, I still need a common denominator though, what am I going to do? Yeah. He's the one that doesn't have anybody, so let's just multiply in sine minus cosine on top, sine minus cosine on bottom. I do have to distribute that. That'd be cosine sine, or sine cosine, however you want to write it, minus cosine squared. Cosine sine or sine cosine minus cosine squared plus cosine squared? Oh, team, what's going to happen to those cosine squares? Yes, where have we gotten?
Oh,
Right, where we check it. Is it our proof? Right, where we wanted to. Now, here's a quick dilemma. When I do it, it looks easy. Right?
Yeah.
When you try it, it might be a little harder. But keep your notes close as we try to finish up this homework tonight. Maybe the problems won't look exactly the same, but the math will be very similar. You might get complex fractions and need to simplify. You might need common denominators put together. You might need to carefully FOIL or distribute a tree. As Colby asked this question, I'm going to start on this one, which we all know what side to choose. Colby, go.
how many more chapters are we doing trig in?
6 is basically the end. Otherwise, it'll just show up every now and
Six
then.
more chapters or chapter 6?
Chapter 6.
Oh.
Sorry, I apologize. I should have corrected. Chapter 6. It's basically the end. So when we come back from break, we're going to have chapter 5b, which will basically get a lot more formulas. We'll have a nice big old huge formula quiz. After break. After break. You can actually look ahead during break and make a formula sheet and start memorizing it. That's a good strategy for you. Then chapter 6, we talk about like law of sines, law of cosines, like non-right triangles. Oh, then we do some vectors, which I guess we're using trees. It's also physics. Hey, has anybody got to look at their formulas and seen that there is a cofunction property for tangent? What is it? Johnny found it? Oh my goodness, can't we just jump to one? Okay, yeah, kind of. Just prove it to me, prove it to me. What can you do to prove it to me?
Write it down.
Okay, write it down. A and B, what can you substitute? Sure, you can make cotangent 1 over tangent, or you can make cotangent cosine over sine and tangent sine over cosine. Either way, what's going to happen as you go to finish? Look at that. It was easy, as long as you knew your So when we have a quiz coming this week, what do you need to study? Formulas, or else you won't have the tools to even build on. Well, you will have hopefully the adding, subtracting, multiplying. It's on the calendar, let's check it.
When we going back for our test?
I had your tests all graded except for the back page, the long answer right triangle problems. So then I should be able to get that done hopefully today. Lots of late nights. I have it at Thursday, unless I decide to skip section 5.3. Unless I decide to skip section 5.3, at which point we might have it Wednesday, because then we'd be basically done today. But we'll see. Either one fewer section on Wednesday or one extra section and then Thursday. Okay.
We only have one more week of school.
Yeah.
Here. Tutoring hours.
Wait, we're done. Tutoring hours. Hey, kids need it. Finals are coming.
Finals next week?
Is that our last one?
Is finals next week?
Not Monday though. Starts on Tuesday. And our final is on Wednesday.
So are we gonna review for finals like this Friday and Monday?
My plan is Friday, Monday, unless we take the quiz on half day Thursday. Unless we take the quiz on Wednesday, then it'll be Thursday, Friday, Monday, and half day Wednesday. Okay. This one's important because there is going to be a homeworky one like this. It's kind of like, because I can't square both sides. I cannot legally, in my proving strategy, square both sides. Colby, wait for the question until the end. Because we have two things to still do, and they both take time. I cannot legally square root 1 plus sine or 1 minus sine because there is nothing that is a perfect square. Somebody a moment ago mentioned something about a conjugate. Andrew, was that? Yeah. So can we multiply by a conjugate and I was like, oh, we couldn't. It just wouldn't take us very far. But on this one, I want something to be squared. Can anybody tell what I want to be squared to cancel out the square root with, looking at our end? What do I want? I don't want him to be squared. I want him to be squared. Can you tell why? If he's squared with the square root, what's going to happen? Squared square root? Just that guy's left. So I'm going to multiply top and bottom by like, all right, fine. You want two of them? I can put in another one. But what I do on top, I have to do on bottom. I'm not squaring both sides. That's not what I'm doing. What I'm doing is multiplying creatively. Like we did with common denominators, but saying, fine, if you want the top guy to be squared to get rid of his square root, I'll do it. The bottom guy, I have no idea what's going on. What happens when we have 1 plus sign times 1 plus sign? Well, I have 1 plus sign squared. Sure, we could FOIL, but the whole point is I want to get rid of that square root. What happens on bottom when I multiply 1 minus sign times 1 plus sign?
1 minus sign squared.
Difference of squares. Ooh, who is 1 minus sign squared? Yeah, cosine what? Squared. And kiddos, the nice thing, the glorious thing about multiplication or division with square roots, you can split it up and do it one by one. And guess what? The squared on top, gone. And guess what? The squared on bottom is just going to be a cosine. He's going to have an absolute value because I need him to always be positive. If you're wondering why doesn't the top have 1 as well, sine can only go down to -1. He'll never make the whole expression negative anymore. Check, D. And we didn't even read the second page. Kiddos, we have a couple minutes left. I want you to take these examples. Your spirals need to be open if you started, which hopefully you did. Your homework from section 5.2. I'm going to quickly go around the room and I need a spot check. As I come to your group, I'm just going to have your group all pulled up their spirals. And if they're all started, then good. And if they're not, then I'll just give you the good, like that. Points. No? What were you doing? I thought I saw T's on there. Okay. T's a no, Andy's a no. Carla's an absent. Okay. John's a no. Thomas is a no. Okay, maybe we'll do it yeses. Okay. Rebecca was a yes. Patricia was a yes. Colby is a yes. Colby is a yes. Kevin is a yes. Kiddos, I'll do another check tomorrow. I'll give half credit to those that now have a good start, yeah?
We don't get points for thinking.
Yes, he's gonna give it to this room.
Right or wrong, too bad.
Killing me, my honors kids. Okay, what am I expecting tomorrow in section 5.2? Squares. Can I take everyone who's gonna look at me? I expect full attempt. Let's get in there, let's get it done. Sound good? Come tomorrow with any ones we have questions on. Here's my plan. Guys, I want you to review sooner. Let's cut out 5.3. We're not gonna do 5.3, we're gonna save it until second semester. We're gonna have a review-ish, question-ish day tomorrow with a quiz on Wednesday. We can start reviewing Wednesday and we'll have all of Thursday, all of Friday, all of Monday. Sound good? Okay. Just 5.1, just 5.2. Get that homework done for me so I can give you half points tomorrow. Colby, go.
Where's the printout for the off-campus?
Oh, you go on website, you go to the homepage for honors, then right here where it says tutoring, there's a link. Right there, off-campus tutoring form. Have your picture ready, fill it all out and show me and I'll be like, sweet, I'll sign off, you'll staple it and it'll count for the hours that it shows.
You would only do half, right?
You can do up to 2 hours unless you've pretty much been in sports all semester, come talk to me, maybe I can let you have 3. Ready, set, go. There's some people that go straight from like football to basketball or to soccer, and they're like, I literally have no afternoons. Maybe I'll let you have 3 hours, but you have to come talk to me separately, not right now.
I've never been one that because he talks so much about it. That's probably the only good part. Oh, I need it. I honestly, I can get it.